Hi, welcome to Office Hour. This is mrs.aladross. Yes.
Alright guys, so today we're going to be talking about scientific notation. So scientific notation is basically just a new way for us to write numbers. Okay, so scientific notation. And we're going to also talk about standard notation. Okay. Now most of us are familiar with standard notation. Standard notation is just the regular way of how you express numbers. So for example, at 400, I have 4 million. I have my number 0.00001. So it's just the normal way that we've been learning about numbers in our classes. And with scientific notation, our numbers are going to start looking like this. So 4 times 10 to the second power, or 4 times 10 to the sixth power, or we have 1 times 10 to the negative, let's see, 1, 2, 3, 4, 5, fifth power. So these numbers that I wrote on both sides, they are actually equivalent, which means they are the same. So 4 times 10 to the second power is the same thing as 400, and 4 times 10 to the sixth power is the same thing as 4 million. 1 times 10 to the negative fifth power is the same thing as 0.00001. Now the reason why we learn about scientific notation is because in science, the numbers tend to get really big or really small, especially when we're talking about things like atoms or particles. And with those things, we talk about them in very large quantities because they're very, very tiny. So we use scientific notation to shorten those numbers. So first we're going to learn how do we convert from scientific notation to standard notation. So with that, usually in scientific notation, you're going to see your number in the ones place. So if you ever see something like 10 times 10 to the second power, this is wrong. Okay, so this is incorrect, because you have a number in the tens place, and you cannot have that. You can only have a number in the ones place, and it needs to be a digit that's either 1 or 2 or 3, 4, 5, 6, 7, 8, 9. So it basically has to be a number between 1 through 9. So you cannot have a 10. And it will have times 10 to the whatever power. Okay, so here the power tells you how many spaces to move the decimal point. So with our first thing right here, 4 times 10 to the second power, so we have 4 times 10 to the second power. I have my 4. Since my 4 is in the ones place, that means my decimal must be right after the 4 to make it, the ones place. And with this decimal, I know I'm going to multiply it by 10 to the second power. And now I just need to figure out, okay, it's to the second power, so I know I'm going to be moving the decimal left or right. And since I'm going to multiply it by a positive exponent, that means my number is supposed to get bigger. So since my number is getting bigger, I'm going to think, does this decimal need to move left or right to get bigger? Right, it needs to go right. So I'm going to move this right 2 spaces. 1, 2. So this is where my new decimal is going to be. And I'm going to be putting zeros in these cups. So 1 0 here and 1 0 here. So the standard form that's equivalent to would be 400. And keep in mind that even though I put the new dot here, I don't write that in my answer. Because if I wrote the dot in my answer, that means I'm saying this 400 has 3 significant figures. And as you can see right here, in my scientific notation form, it only has 1 significant figure. Because the way we count significant figures in scientific notation form is we count how many significant figures it has before this multiplication sign. So since this one has 1 significant figure, which is 1 sig fig, my answer must also have 1 sig fig. Okay, so I hope that makes sense. And okay, so we just did an example on a positive exponent, so let's do one on a negative exponent. So I'll do this one right here, the last example. So 1 times 10 to the negative 5. Okay, so in this case, actually I'll do a different example. Let's see, 5.1. Okay, so we have 5.1 times 10 to the negative 5. So in this case, since it's a negative exponent, I know this 5.5 is going to become smaller since I'm multiplying it by a negative number. Okay, so the only way for this 5.5 to get smaller is if I move the decimal to the left. So that way my number gets smaller. So I have my 5.1. I'm going to move the decimal 1, 2, 3, 4, 5. Oops. Erase that. Okay. And let me put my decimal there. And I'm just going to put zeros in those cups. So my decimal moved over. And I'm going to put a 0 in front of the decimal too, just to make my number nice and clear. So my answer, right now it's in scientific notation form, my answer in standard notation is 0.0000051. Okay, so notice how I just moved the decimal over 5 places. 1, 2, 3, 4, 5. And that means these two are equal. Okay. Alright. So I hope you guys understand from those 2 examples on how to change from scientific notation form to standard form. So with this one, how to change from standard form back to scientific notation. Let me do some examples here. So first example number 1. Okay, let's see. If I have a number that looks like okay, 4899.1. The first thing I have to do is, okay, I have my decimal right here. I know for it to be in scientific notation form, it has to have a number only in the ones place. And that one number in the ones place has to be a digit between 1 through 9. So, okay, I look over at my decimal and I'm like, okay, how do I get a number in the ones place? So that means I have to move this decimal 1, 2, 3 in between the 4 and the 8. So that way I have 4.8991 times 10. And I know I moved 1, 2, 3 spaces. So I'm going to put a positive exponent up here. Now the way you check if you put the correct exponent is you think, okay, so I have my 4.8991. If I want to change it back to the original number, which was 4,899, does this number right here, 4.899, needs to get bigger or smaller? Right, this number, 4.8991, it needs to get bigger. So the only way it's going to get bigger is if I multiply it by 10 to the third power. I have to multiply it by a positive exponent. Okay, so if I multiply it by a negative exponent, it would have made this number, 4.8991, smaller. So I know I cannot multiply it by a negative exponent. Okay, let's do a second example. So example 2. So what's going to happen if we have 400? Well, actually, no, we already did 400 up there. So let's do 4,000. Okay. So first, I'm going to identify where is my decimal. You know, some of you might look at this number and be like, oh, it's right here where the comma is. But no, decimal and comma are two different things. The comma tells us what place this is in. So this is in the thousands place. You know, this is in the hundreds place. This is in the tens place. And this is in the ones place. So the comma just tells us what place it's in. It doesn't tell us anything else other than that. So it's not a very useful thing. So we don't care about the comma. We just ignore the comma. Okay, so I'm going to think, where would my decimal be? Okay, so I know this is 4,000. This is in the hundreds place, this is in the tens place, this is in the ones place. In order for this to be in the ones place, that means the decimal must be right here at the very end, because this is in the ones place. Okay, so now I identify my decimal, and I know my decimal needs to be right after the ones place. So I'm going to move my decimal 1, 2, 3 spaces over. So this will become 4 times 10. I'm going to think, okay, I move 3 spaces. Is it going to be positive or negative 3? Okay, so I think to myself, okay, I have the 4 here. In order to make it 4,000 to go backwards, it needs to get bigger. Oops, it needs to get bigger. So I have to multiply it by a positive exponent. So it's going to be 3. So 4 times 10 to the third power is the same thing as 4,000. Yep. Okay, so with these examples that I just worked through, these are smaller numbers. But usually in science, and later on you'll start learning about moles. A mole is 6.022 times 10 to the 23rd power. And with a mole, imagine if you were to write this number out. It will be huge, because 23 means you have to move 23 spaces over. You have to be moving 1, 2, 3, 4, 5, 6. Yeah. That's way too big. And that's the reason why we learn about scientific notation. So we don't have to write up all those zeros. Because no one wants to do that. No one. Okay, so I hope with this you're able to learn how to convert from scientific to standard form, and standard form back into scientific notation form.